This is a P1 video from the topic energy, looking at multi-step calculations using gravitational potential energy and the kinetic energy equations. So the information that we're given at first, I've done it in stages, is that we've got the gravitational potential energy equation, which makes a lot of sense. Okay, if we lift an object, the amount of gravitational potential energy it's got depends on its mass, the gravity pulling it down, and how high we move that object. So we're told in the question, a roller coaster car has a mass of 1,200 kilograms and is lifted to a height of 44 meters. Calculate its gravitational potential energy store. Now there's 4 pieces of information in the equation, and we've only been told 2 pieces of information. In questions like this, they will want you to assume that gravity is 9.8 newtons per kilogram. So you're going to have to recall that one from memory so that you've got 3 pieces of information to be able to calculate that gravitational potential energy. So here's my gravitational potential energy. I've substituted into the equation. I haven't had to rearrange it. Okay, just to confirm, you can take the gravitational potential energy, cover it up, and it's mass times gravity times height. And I've put in the mass, 2,200, the gravity, 9.8, and the height it's lifted to, 44. And when I work that out, I get 948,640 joules. So that is a straightforward calculation. We've worked out how much gravitational potential energy the roller coaster car has when lifted to 44 meters. Let's see how we can use that for the next question. Now, we make this assumption that all of the gravitational potential energy is converted into kinetic energy. And the question now says, how much kinetic energy does the car have at point C? So we just calculated for 44 meters, point A, and we need to know how much kinetic energy there is at point C, which is 39 meters high. And if we assume that all of the gravitational potential energy becomes kinetic energy, if we work out the gravitational potential energy here at point C, then we can work out the difference between those two, A and C, and we can work out how much kinetic energy it's got at point C. Let's work this through. So we calculated on the previous page that the gravitational potential energy at 44 meters was this number here. And we're now going to work it out exactly the same equation using the gravitational potential energy equation. We've just changed it to 39 meters here for the height at point C. So once we calculate that, we get that the gravitational potential energy at point C, 39 meters, is 840,840 joules. Okay, so this means that at 39 meters, if all of the gravitational potential energy converts to kinetic energy, and at A we had this much energy, at C we've now got this much gravitational potential energy. So the difference is the amount that's been converted to kinetic energy. So the total gravitational potential energy here minus the gravitational potential here gives us the difference in gravitational potential energy that has been converted to kinetic energy. Okay, now we can take that figure, 107,800 joules, and we can use it in the kinetic energy equation. Now this one's slightly trickier to get our head around. Okay, we've got kinetic energy is half times mass times speed squared, and we can see it in our formula triangle too. We've reminded ourselves that the roller coaster car has a mass of 2,200 kilograms, and we have just found out that at point C it has 107,800 joules of kinetic energy. So let's work out its speed at point C. Now to work out this rearranged speed equation, I've covered speed and I've got kinetic energy divided by half times mass. Okay, and then because speed is squared, That's why I've put the square root sign around the equation. Okay, that's the last thing I'm going to do. So I've substituted in the information that I know. I know that the kinetic energy at point C is 107,800. I know the mass of the car is 2,200, and there's my half. And it's important that you put this bit in brackets because it makes the calculation work better on the calculator. If you just typed it in as 107,800 divided by 1.5 times 2,200, you're not going to get the same calculation as if you put that in brackets first. So I've done this section. I like to do things in stages. So I've done, this section here, and I've got my answer as 98, and it's just about square rooting it now. Okay, so I've got my answer here. I square rooted 98, which gave me this long answer. It was much longer on the calculator than that, but I chose to go to that many significant figures for now. And then I went back to the question, which would probably say two significant figures. Okay, so that allowed me to round up this 89 to 9. So I got myself 9.9 meters per second to two significant figures. Okay, hope you found that useful. Thank you.